Spencer, stop. All right, lights, please. Thank you. All right, so let's talk about the quiz. Thank God it was not what I thought. This morning we were thrown into, hold on. This morning we were thrown into a bit of an awkward situation because we had a faculty meeting and it screwed up my normal preparation for class, so I don't have homework answers today to show you. And it also means that mentally I just wasn't as locked in as I normally am. I thought today was the third quiz in the series. It's only the second. And as I was grading your quizzes, I'm shaking my head going, I can't believe that this is the third day of this quiz and they're still making such and such a mistake. So, the good news is, there's one more quiz in the series. The bad news is it's a Monday. Often, when students get Saturday and Sunday off, and they're less likely to work, when they come in on Monday, things are not so good.
Yep.
I would suggest that you put some time in this weekend, because the mistakes that I see being made are very correctable. They're not, for the most part, mistakes of complete misunderstanding where kids are clueless. It's little things that are getting you wrong. So I think that if you just pay a little more attention and drill it, work it a little bit, I think you'll be fine. So let's take a look at this first question. 3x cubed minus 75x. One of the things that I saw that was very good is virtually every kid knew to get a greatest common factor. On the downside, a number of kids forgot the x. Okay? There's a 3 and there's an x. Then, a couple of kids forgot to factor the x squared minus 25. What's the key word in there that tells you that this is a specific way to do it? Anthony?
Completely.
Completely, very good.
2 steps.
2 steps, that's right. Completely is always an indicator that there's 2 steps involved. So the first step is the 3x, the common factor, greatest common factor. Then it's to factor the difference of 2 perfect squares. 2 over here, x plus 5, x minus 5. Yes, Anthony?
But I think the reason why I might not have done it is because why I might have not done it on the first quiz is because there's no plus x or minus x there.
That's right, and you need to recognize, there needs to be something in you that when you see a binomial like x squared minus 25, mentally you have to confirm it's a minus, and then that you can square root both the first and second term, and then it's that special case we call the difference of 2 perfect squares. Okay, now we go to number 2, and I definitely saw a better sense of direction today than I did yesterday. There's no question about that. So in that way, today's quizzes were not disappointing. They were disappointing. If this is what the third one looks like, we got problems. If this is the second one and you're progressing and getting better, then we're good. All good. First thing I'd love to see on your papers that I didn't see on a lot of people's papers is what I wrote in the upper left there underneath the number 2. First consecutive odd integer. Second consecutive odd integer. Why did I emphasize the word odd? Spencer?
Means that instead of adding +1 like you normally would, you'd add +2.
That's right. Odds is +2. Evens is +2. Regular consecutives is +1. Question, Anthony?
You would also add 2 if you're also trying to find out 2 even integers.
That's right. Okay. Now, it says their product means to multiply, is 63. So the first term, x, times the next term, x plus 2, has got to equal 63. Then I distribute, and here's where, now that I've taught you for just about a half a year, I think I have a pretty good idea of your intellect level. What comes easy to you, what is a little more difficult. And I think I have seen every kid firing on all cylinders when they're working well and learning well. And I think I've seen each of you when you're not doing quite so well. When I see kids set up x times x plus 3 and then distribute and get x squared plus 2x is 63, and then I see them getting it all on one side, this is looking very good. And then I see kids factor, looking good. Then I see them solve, and then I see them stop here and say that the answers are -9 and 7. Well, then I say to myself, okay, they did one of 2 things badly. The first one is, perhaps last night they didn't take a couple of minutes to look their quiz over. Talk in the hall, like we mentioned. Or, the other possibility is that they never bothered to listen in class. When I said that, when we come up with these two possible answers, a lot of kids will think that the answers are -9 and 7. Can someone please remind the class as to why the answers are not -9 and +7? Come on, I mentioned this twice, 2 days in a row now. Jano?
Because -9 and +7 make -63.
That's right. That's exactly right, because -9 times 7 is -63. Each of these generates their own pair of answers. So the first answer, -9, you have to go over here, plug it in, God bless. -9 plus 2 is -7, so that's the first set of answers. And the second answer, 7 add 2 is 9. So one pair of answers is -7 and -9. The other pair of answers is 7 and 9. Look, the way I grade this thing is I'm trying to grade it the way that the state would grade it on their assessment test, or the way they would tell me to. This would be worth about 3 points on a state test. And they would say, you get 1 if you do anything right. You get half credit, which in this case, well, let me go backwards. If it's more wrong than right, you get 1 point out of 3, which in my mind is 25 out of 75. If you're more right than wrong, you get 2 out of 3 points, which is 50 out of 75. And then if you're perfect, you get 75 out of 75. And if you're completely clueless, you get 0 out of 75. So we need to make sure that you understand that if you don't take the step and go from -9 and also get -7, and then +7 and also get 9, you are going to lose 1/3 of the points, even if all the rest of your points at work is perfect. And it seems unfair, but that's the way the state wants us grading things. So make sure you're on top of it. Any questions about that? Okay. Now we go to today's lesson sheet. I would like you, today all we're going to do, all class is about today, is setting up learning. We're going to begin to work on establishing a pattern. The concept that we're learning starting today is called completing the square. It used to be taught in 11th and 12th grade. It used to be taught in 12th grade, not even 11th grade. 11th for accelerated. So you're basically learning this 3 years earlier than most students would have learned it just a couple of years ago. Now, when I first started teaching this, I thought the kids would struggle greatly on this material. But it works out that a couple might, but the vast majority will do really well. I take 3 days to get into completing the square so that you understand it completely. All we're going to do today, I don't want to put too much stuff out there. All we're going to do today is notice and look for a pattern. Once we're done noticing and looking for a pattern, we're stopping. No great conclusions today, other than to see the pattern. So, I would like you to fill in the first 4 rows of this. All right, so, and by the way, I want to make sure, we talked about this a little bit yesterday. We talked about the 1x plus 5 squared. What does x plus 1 squared mean? X plus 1 times x plus 1. So over here, you should write x plus 1 times x plus 1. And then you should do your work here for distributing and then writing your standard form here. I would like you to do that for the first 4 rows. I'll take attendance, and then in a couple of minutes we'll show you how to do this. Emma, that's, you got that down there, right?
Mm-hmm.
Okay, thanks. getting the idea that you guys are pretty close to done. So, all right, again, all we're going to do today is look for patterns. We're not trying to get too deep. And then, of course, it being a 2-day weekend, we're going to have to kind of revisit this a little bit on Monday. All right, so if I write the factors, I'm going to get x plus 1 times x plus 1, and then double distributing, and this is the only one I'm going to draw these hoops for. After this, I'm going to expect you to begin to sense the pattern. X times x is x squared, x times 1 is 1x, 1 times x is 1x, 1 times 1 is 1, and I get x squared plus 2x plus 1. Okay? We good? Okay. Next, x plus 2 squared would be x plus 2 times x plus 2. And I really want to emphasize that to square something does not mean square the x, square the 2. It means take something and multiply it by itself, which means the whole x plus 2 must be multiplied by the whole x plus 2. That would be x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Are we good? Everybody good?
Yeah.
Am I leaving anybody behind here? Okay, let's go to the third one. X plus 3 squared means, louder,
X plus 3 times x plus 3.
x plus 3 times x plus 3. We all know that you are quite capable of being loud if you want to. So this would become x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. Good? Okay. What does x plus 4 squared mean?
X plus 4 times
X plus 4 times x plus 4. Oh, hey, you're supposed to be black. Hey! There we go. X plus 4 times x plus 4, which is x squared plus what?
4
Plus?
plus 4 x
Plus,
16
which all together is?
X squared plus 8x plus 16.
Good. So, do we notice a pattern here? You notice the pattern that this was a 1, and that was a 2, and then that stayed a 1. This was a 2, this was a 4, that became a 4. This was a 3, that became a 6, that became a 9. That was a 4, this became a 8, and this became a 16. So what do I notice from the pattern? If I wanted to just look at x plus 5 squared and skip these two middle columns, what would I get here at the end? Janelle?
You always know that the middle terms are gonna be the same, so you would just add them together.
Which amounts to
Amount.
doubling it,
Okay, yeah.
right? Because there's 2 of them.
Yeah, so it's.
So it's going to be x squared plus 10x, because, right? 4 and 4 was 8, 3 and 3 was 6, so then 5 and 5 would be 10.
Every time the second column, like the plus 1, plus 4, plus 9, plus 16, it's increasing by consecutive odd integers.
That's a great way to look at it, because that is the pattern, but another way to look at it would be it's squared.
Yeah.
1 squared, 2 squared, 3 squared, 4 squared,
5 squared.
5 squared.
5 squared.
Good, what would the next one be? No, so let's start, now, hey, careful now, that says 20. Doesn't say 6, says 20. Let's think.
It would be x squared plus 40x plus 400.
That's right. X squared plus 40x plus 400. In other words, this guy here, 20 times x, gets doubled to make the middle term. Doubled because there are, when we look at these, right, there's always 2 of them. That's why it's doubled. And then, and it only works that way because it's the same number being squared. And then you square to get the last term. So that's the first part of today's pattern that I want you to notice. I want you to notice that when you square a binomial like x plus 5, you're going to get x squared, but it's not x squared plus 25. In the middle is going to be 10x. Because when we double distribute, in the case of the 4x one, there's going to be a 4x and a 4x. In the 3x one, there's going to be a 3x and a 3x, etc. Got it? Okay, so far, again, all we're doing today is looking for patterns. And once we see this pattern and feel comfortable with the pattern, What the pattern does is it saves us time. So if this is the standard form, what's the factored form? Does anybody think they know the first one just by looking at it? What do we see there? Mr. Egan, do you notice anything?
It's not like just squared.
Well, that's a true statement. We're going backwards here. So this would be the last column. What would have been the first column?
Would be x plus 6.
That's right.
squared.
That's right, x plus 6 squared. How do I know that? Listen very carefully to this phrase, as this phrase will be a phrase that we use a lot over the next 3 days. Half and square. What'd I just say?
Half and square.
And this is really the heart and soul of this technique called completing the square. Look, what's half of 12?
6.
And what's 6 squared?
36.
So it's half, x
Squared.
plus 6, and squared.
36.
Okay, what would the next one be?
Oh,
Anthony?
x minus 6 squared,
Good.
not plus.
Now, what has happened is we could actually try to do the AM method on this, but because this fits in with a half and squared technique, this is a little bit of a time saver. It's like a special case, okay? Like when we factored x squared minus 49, we saw that we could square root both of them. Same idea here. X squared plus 20x plus 100. Sarah?
X plus 10 squared.
Good. Right? What are those 3 words I want you to remember from today?
Half
Half and square. What's half of 20?
10.
10. And then all you do to check and make sure you're doing it right is, does 10 squared equal 100? If it does, then you're factoring it correctly. If it didn't, it'd be, whoa. No, that doesn't work this time.
Whoa, whoa,
But if
whoa.
it works, it's there.
Oh, no.
All right, let's have a little fun here. Up in the game.
I already figured out the answer.
Oh, this is a good thing. I'm gonna give everybody about 15 more seconds to figure this answer out. Follow the pattern.
I didn't like it.
Carissa's looking at it incredulously. Lena wants to hit it.
Oh, that's great.
Oh, don't you be a wimp. Be a free spirit now. Come on, a mathematical free spirit. Spencer.
1.5.
Yeah, if you don't mind, I'm gonna write it 3/2. Now, why did I write it this way? Check it out. What's 3/2 times 2? 3, right? The 2's would go die-die. And then, what is 3/2 squared? 9/4. So even yeah, not so bad, huh? It's like Rocky. It's like Rocky fighting a Russian guy.
Rocky
The one who
Road.
said, "I will break you." Pounded him, and Rocky go, "Ain't so bad,
Rocky Rock.
ain't so bad."
It was
Rocky 5 was horrible.
That's it, ain't so bad. So, again, it's half and square is the pattern we're looking for. What do you think the next one would be?
What about first one?
Looking for someone who hasn't helped me yet.
Well, my new name is
Sydney?
X plus 50 squared.
X plus 50 squared, good.
Yes?
No,
Nice.
It's not x plus 500.
What about the next one?
Oh no.
Oh man.
What's the problem?
Because
All
I know what the problem is, but I thought I did it.
right, what's the problem? Because there is a problem. What's the problem?
That they don't have it. Yeah.
Yeah, the thingy in the middle there, right? The middle term, the coefficient, the 8, if I square it, do I get 3?
No.
No.
Oh man.
This is the point at which I'm going to leave you off, because this introduces Monday's lesson. Watch me now. X squared plus 8x plus 3.
Yeah, I also did Monday.
I don't please stop. I'm trying to learn.
In order to make this a perfect square, I would need to add 13 more. Agreed?
Can we just do
Where
that?
did the
Oh,
13 come
we'll get
from?
to
So
that.
when you add 13?
Does everybody see that I need the 13 more?
Yeah.
Right? Because half
Yes. Nice.
and
Square.
square. So this needs 16, so I need to add 13 more. Now, isn't it true that the 3 and the 13 are contained because of the 4 squared?
Mm-hmm.
So then to balance it out, I need to write minus 13 out here.
Oh.
Because if I add 13, and then I later subtract 13, isn't it equal? Think about your favorite number. I love 7.
I have
What's 7 plus 13?
15.
7 plus
I think
13.
my favorite number.
right, well, let's work with me here. 7 plus 13. Minus 13. Back to 7. So if I add and subtract, the same thing, guys, come on. Listen, if I add and subtract the same number, I always get back what I started with. So what we tried to do today was to show you a pattern about half and squares. The pattern worked all the way through the 5th term. When it doesn't work, I have to get a little creative. The way I get creative is I say, well, if I half it and square it, I really needed a 16. Since there's only a 3 there, well, I'm going to add 13. Now, if I just add 13 and I don't change it back, kind of like plan B factoring, then I've altered the question. But if I then put a minus 13 here, I've balanced it out. Okay? All right. That has us covered. Spencer, I am having a intense deja vu over the last week and a half.
Why is that?
Well, the picture on the cover of the newspaper site I looked at while you guys were finishing your quiz, I swear I've seen it before, but I haven't seen it before.